The technological advances made here might well end up being used under the impenetrable Arctic gas fields. By the time this pipeline gets into full production, the huge army of divers, welders, engineers and construction people will already have moved on to other projects, leaving behind them a super pipeline hidden deep under the North Sea.
Megastructures is back at the same time tomorrow. After the break, why two of the world's most important historical sites are under threat.
It's one of the gas industry's riskiest ever projects, the construction of the longest subsea pipeline in the world. Giant ships will lay 100,000 pipes linking Norway to Britain, while space-age robots trench an underwater moonscape beyond the reach of human hands. But will the finished result survive the brutal North Sea? "120 kilometers off the coast of Norway is one of the North Sea's largest underwater gas fields. 40 kilometers long and 10 kilometers wide and containing over 300 billion cubic meters of gas. It's called Ormen Lange. Ormen Lange is locked in an icy tomb 3,000 meters below the sea, so deep and so remote that it's considered beyond the reach of man and machine. But the engineers at the Norwegian energy company Norsk Hydro decide that it's too tempting to ignore, because it contains enough gas to supply 20% of the UK's needs for 40 years. The Norwegian engineers know that there's an expanding market for natural gas in Britain, because the coal traditionally used to power the economy there is no longer sustainable. Foreign gas is increasingly being used to power the turbines that create the electricity for homes and factories, and the country needs more of it. So the engineers come up with a plan. It will take 10 years and cost $10 billion US. First, they'll drill the Ormen Lange gas deposit, transport the gas 120 kilometers to one of Norway's largest processing plants at Nyhamna, and then send the processed gas down the Langeled pipeline to the UK. A total distance of 1,200 kilometers. But to build the world's longest subsea pipeline this far and this deep will mean overcoming some major obstacles. They'll need to drill nearly 2,000 meters through the seabed to tap the gas field. To do this, they'll use a rig built right on the sea floor. But the first problem is the Storegga slide. The pipeline that will bring the gas out of the field and deliver it to the plant has to scale this 300-meter underwater cliff face. And the terrain of the sea floor is too rough to lay pipe on, so they'll need to trench it. The gas itself is a dangerous mixture of debris and frozen water, capable of blowing a processing plant apart, so they'll need to adapt the system to handle this gas. The plant is big enough to turn through 70 million cubic meters each day. To handle this massive job, they amass some of the largest industrial ships in the world, each designed to tackle a specific phase of the deep sea construction. Out here in the harsh North Sea, humans are confined to the topside world. But beneath the waves, the brawn work is done by underwater remote-operated vehicles, or ROVs. These machines are so technologically advanced that they're almost the stuff of science fiction. It's a monumental challenge, but with so much gas industry money behind them, the engineers can dare to dream. But are they going too far? Can they make the dream come true? Or will the project become a nightmare? First, they search the world for a gas well platform which will work in these torturous seas. Existing designs all fall short. The weather here is too stormy and the water too deep. So they come up with an ingenious solution. If they can't bring the gas up to a rig, why not take a rig to the gas? Inside this warehouse in Tonsberg on the coast of Norway, the key to solving this engineering challenge is built. In a daring move, the engineers combine the function of a surface platform with a seabed drill guide. Called a template, it's essentially an underwater gas platform that will guide the drills through to the gas field and control the well flow. Conventional gas platforms are surface structures manned by an army of workers. But in this case, the platform will be dropped onto the seabed where it's clear of the wild North Sea weather. A drill ship will then dock to it and from above guide the drills through to the gas field. When the drilling is flowing, the drill ship will depart, leaving the template to control the wells. 4 of these monsters will be mounted onto the seabed, and through them, a total of 24 wells will be able to siphon over 70 million cubic meters a day from the gas field. The template will then direct and control the gas flow to a shore-based plant. The entire unit will be operated by remote control from a manned center 120 kilometers away. Richard Bainan is a subsea engineer.
The main thing that you've got, the difficulty that you've got, is it's dark, it's the devil of a job to put it in the first place. You've got to get this equipment onto the floor. It's highly valued, highly priced piece of equipment, and then you've got to put it together with robots and you've got to make sure it doesn't leak. Apart from that, it's easy.
The stakes are huge. The engineers have to build it to withstand pressures that would crush a normal submarine, and it has to operate flawlessly for more than 40 years in a harsh saltwater environment. Once it leaves this warehouse and is lowered to the sea floor, there'll be no going back. It will be committed to the seabed forever. The 1,000-ton structure can't float on its own, so it's loaded onto a seagoing barge for transport to the drop site. With all the planning and building behind them, it's now the weather that will determine if the mission is a success or a failure. They plan the 4-day journey to the drop site to coincide with summer, the season of the calmest seas. Not that that means much out here in the North Atlantic. They rendezvous with the world's largest crane ship, the Thialf, a super crane that does heavy lifts at sea. The 2 cranes mounted on board can lift over 14,000 metric tons, about 80 747 jumbo jets. The barge and Thialf wait for a weather window before lift operations can begin. The contract to install the subsea component is worth $21 million. With so much at stake, they do a practice run back on shore. The crane and ROV operators rehearse the drop in a 3D virtual underwater world to simulate the one they'll be working in. Weather, depth and weight will all be against them. Finally, it's time for the real thing. Lines are connected, and the record-breaking sea drop begins. This is their only chance. If they miss, and the structure settles on the seabed in the wrong place, they'll have to build another one and set the project back by a year. Computer-controlled thrusters hold the crane ship over the drop site. As it drops below the surface, the underwater ROVs go into action and take over as the eyes of the operation, feeding video back to the control room. The engineers scan the rig for problems as the pressure increases. From 1,000 meters below, the ROV sends video back to the crane operator, who then adjusts the orientation. The ball bearing has to be kept as close as possible to the center of the bullseye. He keeps the drop going even when it's just meters away from the sea floor. There's no stopping it now. The template is down, and so heavy that the legs on the base sink 8 meters into the seabed. But the engineers won't know if they've hit the right spot until they check the coordinates. Readings show it's within 40 centimeters of their target, close enough to be considered a perfect drop, and it was accomplished from 1,000 meters above on a rolling sea. Now that the template has been successfully placed, the next step is to tap the gas field.